Hi, I'm Liz Nedden. Let's have a look at the standard normal distribution. So we use the notation Z, or the letter Z, to describe the standard normal. And the standard normal always has a mean of 0 and a standard deviation of 1. Now the reason that we have this distribution is that all other distributions can be converted into this distribution. We can calculate a probability and then we can turn it back into the other distributions that we want. Because there are so many different means and standard deviations we could have, that's why we need a standard normal distribution to be able to compare to. So we want to be able to convert from any distribution x to this z distribution. So this distribution on the left here, that it was my x distribution, and it can have any mean. So it could have the mean of anything it likes, and it could have any standard deviation. And we convert that to our z distribution, which has a mean of 0 and it has a standard deviation of 1. And there's a little formula there that is used, that's the formula that does the converting between these two distributions. And it can go both ways. So here's a little example, and I want you to notice that this little line that's showing here, that blue line, that is my z value, and I want you to notice what happens as my x value, which is this little pink line here. When I play this movie, I want you to notice what those two lines are doing. And so as we are converting between an x and a z, we can see that these lines are moving at the same rate in terms of the area that is below it is the same. So the probability of being below that x or z value, the probability is the same. So any distribution can be taller, skinnier, narrower, wider, whatever. So any mean, any standard deviation, that is going to give us a different range of values, but the probability will remain the same. So as my x value changes, so does the z value. If I'm below the mean, it's negative. If I'm above the mean, it's positive. So we're going to look into this in more detail. So if I talk about the heights, and I say, well, the heights of this group of people has a mean of 150 centimetres and a standard deviation of 5 centimetres. I'm going to first of all put my x values there. So there's my heights. And you can see I've got the mean at 150 right bang in the middle. And then I've gone up by 1 standard deviation and down by 1 standard deviation on each side. So I'm going adding on 5, taking away 5. And so that gives me my equivalent z values, which are 1, 2, 3 standard deviations above the mean, or -1, -2, -3 standard deviations below the mean. So these x and z values are equivalent by using the formula. So the z value of -3 is equivalent to the x value of 135 for this distribution. And I can show that if I substitute that x value of 135 into the formula, minus the mean, which is at 150, and divide that by the standard deviation of 5, that will give me a z value of 3. And you can see that's why these two values match up. The value of 140 will be equivalent to a z value of -2. The x value of 145 will be equivalent to a z value of -1. The mean of 150 is equal to the mean z value of 0, and so on. You can see that each of these values are going to align, and that's an important thing to know. So if I did 140 minus 150 divided by 5, I would get the -2. And I can substitute all of those values into the formula and show that they are equivalent. So let's look at an example here when we're talking about the cheese weights. We've got a mean cheese weight of 1,004 grams and a standard deviation of 2 grams. So if I have a cheese which weighs 1,007 grams, I want to find what the equivalent z value is. So I'm going to subtract the mean, which is 1004, divide that by the standard deviation of 2, and that will give me a z value of 1.5. So what that means is that x value, the cheese weight of 1007 grams, is equivalent to a z value of 1.5. And z values don't have a unit, by the way. Let's try a different example. If I had a cheese which weighed 999 grams, subtract the mean, which is 1004 grams, divide by the standard deviation of 2, and that gives us a z value of negative 2.5. So that cheese weight of 999 is equivalent to the z value of negative 2.5. Thanks very much for watching.